Welcome back to the Health Longevity Secret Show, and I'm your host, Dr. Robert Lufkin. Today, we embark on a profound exploration of the relentless pursuit of longevity through the lens of Dr. Aubrey de Grey. The acclaimed biomedical gerontologist shares his vision of aging as a machinery-like degradation. He discusses his shift from computer science to gerontology, which is driven by the urgent need to confront our biological clock. We witness how the landscape of longevity research has rapidly evolved, with significant funding milestones becoming a testament to the progress within the field. From the inception of the Methuselah Foundation to the SENS Research Foundation, we trace the influx of investments from early-stage venture capitalists and the visionary crypto community, who view aging as a challenge that can be technologically surmounted. The episode also delves into the impact of decentralized autonomous organizations and the philanthropic gestures of individuals like Vitaly Buterin, who have become instrumental in catalyzing groundbreaking research in longevity. As we dissect the intricate dance between stress and aging, we shine a spotlight on the rejuvenating promise of SENS strategies and the marvel of centenarians who exhibit superior stress management. The episode navigates the turbulent seas of mitochondrial function, ATP production, and the generation of detrimental free radicals, advocating for repair strategies over antioxidants to enhance lifespan. Step into the future where the secrets of extending human life are closer than ever before. This episode is brought to you by L-Nutra, maker of the prolonged fasting mimicking diet. Please support this podcast by checking out their website and taking a look at their amazing products. And now, please enjoy this week's episode.
Welcome again, everybody, to the Reversing Inflammaging Summit, Body and Mind Longevity Medicine. Today, we're honored to be speaking with Dr. Aubrey de Grey, a biomedical gerontologist based in Silicon Valley. And I'm happy also to introduce my co-host, Dr. Robert Lufkin.
Hi, Steve. I'm so glad to be here today, and I'm so excited to have Aubrey de Grey with us. He never fails to have fascinating things to tell us about his take on longevity. So I can't wait to get into it.
Thank you, Rob. And now here's our interview with Aubrey de Grey. Welcome, Dr. Aubrey de Grey. It's a pleasure to have you here, along with my co-host, Dr. Robert Lufkin. And to kick off our discussion, the audience would love to know what brought you into this arena and what really excites you about this area.
All right, yes. Well, first of all, thank you so much for having me on the show, the two of you. I'm delighted to be here. What brought me into the arena really was the realization at the age of about 30 or so that there were so few other people in the arena. I had always, since I was a young kid, decided that I wanted to dedicate my life to one or other of the hardest and most important problems for humanity. And in my early life, through until about the age of 30, the one that I ended up working on was the problem of work. The fact that so many of us have to spend so much of our time doing stuff that we wouldn't do unless we were being paid for it. I thought, right, therefore, we should definitely develop artificial intelligence and have more automation so that that's no longer the case. And at the age of 15 or so, I started programming and found that I was pretty good at it. So that's why I went into that area. And my undergraduate degree was in computer science, and I did AI research for several years thereafter. But during that time, I met and married a biologist. And the result was I not only accidentally learned a lot of biology, I also eventually began to realize that neither she nor any of the other biologists I was meeting were actually interested in aging, which struck me as completely crazy, and it had something that had never occurred to me until that point, that biologists would not view aging as, by some distance, the world's most important problem. But it turned out that that was the case. And then, digging a bit, I found that the few biologists who were working on the biology of aging were, in my view, not going about it very well. So I thought, well, I better switch fields, really, and I happened to be in a position where I could do that without much risk. So here I am.
That's great. Well, there's one question we always ask all our speakers here, just to sort of set the stage, in addition to the background and how you got here. But it's kind of how do you view aging? What is longevity? Why do we age? And it's interesting because our speakers all seem to look at this from a slightly different angle.
Yeah, it's astonishing, really, that even people who are experts in the field, have a wide range of answers to that question. You would think that, since we've been preoccupied by it since the beginning of civilization, that there would have been a consensus reached, really. But there you go. So yeah, I mean, my view of aging, my definition of aging, is perhaps a little distinctive simply because of the way in which I arrived in the field, starting out in an engineering discipline, a technological discipline. So I look at aging, from that perspective, really, looking at the body as a machine, obviously a very, very, very complicated machine, but still a machine. And therefore, I look at aging in a very down-to-earth way, the way I would look at aging of a car or whatever, just that it is the lifelong accumulation of self-inflicted damage that is created as a consequence of the machine's normal operation, and that the machine is set up to tolerate only a certain amount of that damage. Therefore, eventually that threshold is exceeded and the machine's function starts to decline and eventually to cease entirely. That's, to my mind, a definition of aging that works just as well for living machines and for non-living machines. And then, of course, there's the question of why it's valuable to do something about it. And there we have a rather different situation where the analogy with cars and airplanes or whatever doesn't apply at all, because we're perfectly happy with the idea of a car basically falling apart and we just buy a new one, but we don't have that option for our bodies. So, of course, the question then is there some kind of, satisfactory limit to how long we would extend the period before the machine starts to decline in function? And to my mind, it's perfectly obvious that there is no such limit, because essentially our attitude to all of that question revolves around how we want our future to be, which has nothing whatsoever to do with how long ago we were born.
Yeah, great thinking on that. I have one thing I want to share with you. The first time I came across your work was, I think, back in 2006, up in Monterey at a TED Technology Education and Design Conference, and I heard you give a presentation there that was just remarkable, and I think that it's still available online on YouTube if you want to search it. But it was very transformative, just hearing you talk about that and your vision at that time for longevity and negligible senescence, which we'll talk about. I'm curious. That was back in 2006, I think, and I'm curious. Since then, now we're in 2020, 2022, 23. What has changed most, or what's happened in the intervening time in the longevity space that's most excited you since that talk?
Yeah, take me back. I was very privileged to be able to speak at such a prestigious conference at a relatively early time during my career in aging. Not very many people knew me until then, but as you say, it was a well-received talk. It's been viewed, I think, a few million times and so on. And of course, at the conference itself, I met various people who became important supporters. And so things have definitely progressed quite rapidly since then, I guess. Not as rapidly as we would like, of course. It never could be as rapidly as we would like. But yeah, I mean, that was when I had just created the Methuselah Foundation, along with my co-founder, Dave Goebel. And a few years later, of course, I created SENS Research Foundation. And, things have gone pretty well since then. At many levels. First of all, of course, in the lab, not only our own lab, but labs all over the world, there has been, steady, well, at least um, cumulative progress towards the goal of bringing aging under comprehensive medical control. And I guess really the most important things for me that have happened that really kind of sea changes to the situation have been the arrival of really serious money from various sources. The first phase of that really started about 6 or so years ago when a few courageous early stage investors started to get involved. Up until that time, essentially all of the important work was being funded purely philanthropically. And, well, at the end of the day, investors write bigger checks than donors do. So when people start thinking that they might be able to make money out of this in the fullness of time, then things start to go faster. And so, at SENS Research Foundation, we transitioned very rapidly to a business model where we would essentially spin projects out as startup companies as soon as there were investors who had an interest in supporting them. And that's happened maybe 7 times now, something like that. And of course, that's just the tip of the iceberg, because alongside us, there have been literally hundreds of other companies that have sprung up doing important work in the areas of longevity and rejuvenation, and being funded from those kinds of sources. And of course, it's not just angel investors these days. Proper institutional investors with very deep pockets have started to come in. And then the second thing, which happened much more recently, really only over the past 2 years, was the arrival of serious money from the cryptocurrency and blockchain community. The reason that has mattered so much is basically because it's a community populated almost entirely by geeks, by people who think like me about aging, who are basically technologists and who very readily understand the body as a machine kind of thing, and the potential for comprehensive, periodic, preventative maintenance to do the job we want of stopping people from going downhill as they get old. And so, yeah, I have been extremely successful over the past, I'm going to say, 5 years or so in enthusing the cryptocurrency community. I would constantly be invited to crypto conferences where I was the only non-crypto speaker just because of the fan base. And over the past couple of years, as I say, that enthusiasm has very much translated into the writing of checks.
Well, just a quick follow-up question on the cryptocurrency space, where Tim Peterson is speaking on our program from Vita DAO. What other is in the cryptocurrency space? Is it mainly the decentralized autonomous organizations that are getting traction, or is it just people with cryptocurrency investments and a lot of liquid capital that you're seeing coming in?
There are really three major things. So the DAOs are very important. Vita DAO is certainly playing a big role, and thank you for mentioning them, because they just gave a grant of $250,000 to SENS Research Foundation just a couple of months ago. So yeah, they are very cool people. I'm very much a fan of that. Then there's the let's call it the grassroots individual donation community, and the biggest example of their involvement was the airdrop that happened last year at SENS Research Foundation. So one of the real big hitters in the crypto community, Richard Hart, a wonderful man who made a great deal of money and indeed his name creating the cryptocurrency Hex. He's very much a larger-than-life kind of character and has a large following of devotees. And rather than, he's been a fan of what we do for a long, long time. He actually volunteered at one of my conferences when he was penurious back 15 years ago. But he decided that he would not just write me a big check the way he could have done, but rather he would mobilize his flock. And so basically last year we were the beneficiary of $27.5 million coming from more than 2,000 donors, almost all of whom were what they call hexicans, people who have done well out of Hex. And almost all of whom were completely new donors who'd never come across us before. So it was a very big deal, and I have nothing but praise for Richard Hart for what he's done in this area. And then the third group within crypto is the big hitters themselves, the people who have made literally, hundreds of millions or billions of dollars out of hacks. The first person out of that community who got properly involved in terms of supporting our work was Vitalik Buterin, the creator of Ethereum. He read my book when he was 14 and was hooked ever since. And once he got into the position of being able to help, he started doing so. That was maybe 5 years ago. But then in the past 2 years, a number of other people have come in and done the same thing. A guy who's not very well known, but outside of the crypto community, but is very well known and respected within it, a guy named James Fickle, who made a lot of money out of Ethereum, started to get involved and put proper money into this. But also, he's the kind of guy who likes to talk, to evangelize. And so he has a number of friends who are even wealthier than he is, and a lot of them have been putting money into the longevity and rejuvenation field over the past couple of years as well. And there's investors as well, like the guy who started Coinbase. Brian Armstrong created a company, funded it to the tune of $100 million. Lots of crypto people have been making big waves in this area. Charles Hoskinson, who created Cardano, has just created a clinic in rural Wyoming. So
yeah, it's great that the field is getting so much financial support. Of course, that's one of the foundations of growing the field. Let's take a step back. Can you talk a little bit about the SENS approach to combating aging that I think you helped to develop?
Sure, absolutely. Yeah, I mean, of course, the reason I wanted to highlight the money at first was because until now, it has been an inescapable fact that the lack of funding in the field has been the rate limiter in terms of the rate of progress. And now one could argue that it no longer is. But yes, so the SENS approach is very simple, really. I mean, as I was explaining earlier, it's really just about looking at the body as a machine and therefore looking at the ways in which we will extend our healthy lifespan and therefore, as a side effect, our total lifespan in the same way that we would do so for a vintage car or whatever. And that comes down to comprehensive, periodic, preventative maintenance. That's all it is. Removing the various types of molecular and cellular damage that the body does to itself throughout life every so often, so that the amount of damage the body is carrying around does not rise to the threshold amount that the body is not set up to tolerate with full function. And this sounds so obvious that these days that it's astonishing really to think back at how counterintuitive it was 20 years ago when I first started talking this way. The people who were working on the biology of aging were completely focused on the idea of instead simply making the body run more cleanly. In other words, damage itself more slowly than it would naturally do. And of course, that's the kind of thing that we get from, for example, calorie restriction or from, for that matter, calorie restriction mimetics and so on. Very, very few people were thinking in terms of removing damage that's already been laid down, even though obviously it is much more desirable because it means that it's actually useful to people who are already in middle age or older. So yeah, that's what the SENS approach is. And the way it ended up being a plausible approach, because of course I had to say not only is this what we'd like to do, it's also going to be easier than making the body run more cleanly. I had to break it down into describing what the damage is that we need to periodically repair. And the way I did that was basically to describe 7 categories of damage, within each of which there are plenty of examples that differ in various ways. But nevertheless, the classification has the great utility that there are generic approaches to actually doing the damage repair that apply across the whole category with differences of detail from one place to another. So for example, one category is cell loss, cells dying and not being automatically replaced by the division and differentiation of other cells. And so, of course, if that happens, progressively the number of cells in the affected tissue declines, and eventually there are not enough for that tissue to do its job. And so I often use Parkinson's disease as the most straightforward example of that. This is a case where, of course, we have a particular type of neuron that dies much more rapidly than most neurons do, such that by old age, all of us have lost maybe a quarter of the dopaminergic neurons that we had in youth. And some people have lost maybe three-quarters, and that is beyond what can be tolerated, and that's why they have Parkinson's disease. So, of course, the damage repair approach is simply to use stem cells to replace these neurons and restore the number of them so that we restore the amount of dopamine there is. And, of course, it's been found that when you do it right, it works. And now we're up to the point where there are clinical trials going on doing exactly that. It took a long time to get here because we needed to figure out things like IPS, things like how to manipulate stem cells in the laboratory before injecting them. But here we are now. So that's just one category. And of course, there are other areas where cells are lost. Let's take, for example, the thymus, where, of course, we have a dramatic reduction in the production of naive T cells as a result of the thymus essentially becoming a chunk of fat. And again, there are approaches to doing something about that, whether with stem cells themselves or whether with growth factors to take the residual cells in the thymus and regrow them, etc. So that's just one category. And of course, as I say, there are different details. You use different stem cells for different tissues. But still, it's very useful from an engineering perspective to have this classification because, of course, once you've got one stem cell therapy working for one tissue, you can reuse a lot of the knowledge that you acquired in getting that one working. So the next one and the one after that are much easier and quicker to actually develop.
Before we get into the details on these, and this is fascinating, I wanted to back up one step and something you mentioned just to sort of underscore it a little bit, the idea of damage repair versus slowing damage creation. And some of our speakers, they're focusing on slowing damage creation, others are on damage repair. And what is it about slowing damage, repairing damage that is much more an appealing target or much more effective than just slowing repair? I mean, I just intuitively, I think if I'm gonna break my arm, it's better not to play on the swing than have a better way of making the bone heal. But that's a naive approach. Maybe you could expand on that a little.
Yeah, you're saying it exactly right. This is precisely what was in the mindset within the community 20 years ago that led them to focus exclusively on slowing down the creation of damage. The fundamental error in it is that once damage has been created, but in the stage before there is so much damage that we get sick, the damage is kind of inert. It's not participating in metabolism, so to speak. It's just sitting there, accumulating. Whereas metabolism itself is, of course, this enormously messy and complex network of processes. And here I use metabolism in the broadest sense, the entire network of processes that keeps us alive. So I'm not just talking about, insulin metabolism, for example, or sugar, whatever. So yeah, it's just so complicated. And the problem is that the creation of damage is inextricably intertwined with the performing of the things that we need the body to do to keep us alive. So if you try to, disentangle them and try to, get the body to not do the thing we don't want it to do, creating damage, you are just going to have unintended consequences that stop it from doing things we need it to do as well. Whereas if you are attacking and removing damage after it's been created, then you're basically leaving metabolism to do what it has evolved to do, and you're not messing with it.
So let me piggyback on that question, because as a psychologist, one of the interesting things that I address is the impact of stress, for example, as well as emotions, trauma, and things like this. Hans Selye, the person who originated the concept of stress in the behavioral field, one of his earliest studies, actually, you mentioned the thymus, one of his earliest studies showed the atrophy of the thymus with stress. And we could look at other impacts, impairment of the prefrontal cortex and the hippocampus where neurogenesis takes place. So how does that fit into how you see the process of longevity?
Yeah, it definitely fits a lot, but it doesn't fit in the sense of defining what types of damage accumulate. Where it fits is in defining how rapidly they accumulate. So absolutely, we understand, as you're pointing out, that stress is bad for aging in general. It essentially accelerates the accumulation of various types of damage, whether it's cell loss or senescent cells or pretty much anything. And we, of course, know some parts of how it does so, the impacts of stress hormones, etc. And, of course, empirically, we see that if we look at, for example, centenarians, there's very little that centenarians have in common. But the one thing that people who study centenarians very often point to that they pretty much do all have in common is nothing bothers them. They haven't really ever necessarily had a stress-free life, but when they get into stressful situations, they ride the wave, so to speak. They roll with it, and that's to me a very important observation. I feel the value of minimizing stress in whatever way, whether it's by yoga or meditation or whatever works for you, right, is definitely, unarguable. But it doesn't really change the question of whether damage repair is the right way to go. It certainly still is the right way to go, whatever.
So the stress reduction would help both in slowing damage creation, but also in improving damage repair, I guess is what you're saying then, potentially.
I don't know. I mean, certainly in slowing damage creation, but damage repair is kind of an exogenous thing. It's medicine, right? We have to actually inject stuff. So I don't really see it as having all that much connection there, except insofar as, of course, you could do the damage repair less thoroughly or perhaps less frequently if you wouldn't necessarily have a different type of damage repair.
I see. And so the SENS approach, and I'm not sure if we define SENS as engineering negligible senescence and all its important concept, and that I think you coined, but it's a beautiful idea. So in the SENS approach, you've been successful at basically developing these techniques and planning for ways to repair damage. What are the challenges now that you're facing? What are the biggest challenges with the SENS approach? And as a follow-up to that, the SENS approach, then it sounds like is mainly doing stem cells and tissue repair that way. Is that correct?
Yeah, not quite. Well, first of all, by virtue of being a divide and conquer approach, where we are developing different techniques to repair different types of damage, we are inevitably in the situation where some of these approaches are easier to develop than others. And at SENS Research Foundation, we've always been very strong on focusing on the things that other people are neglecting. And at my new foundation, that's going to be the case as well. The point there, of course, is that once something is already kind of far enough along that investors and big pharma or whatever are up for it, it gets into clinical trials and so on, then kind of it's got a life of its own, and it's kind of not something that I feel I need to focus on. And we are pretty much there for some stem cell therapies, and also, of course, for some senolytics, drugs that selectively kill off senescent cells, which is one of the other strands of SENS. But there are other things that are not quite that far along. One thing that I've been focusing on for a very long time is the removal of waste products. And I've always defined that in two different categories within SENS, distinguished by whether the waste product is inside the cell or outside in the spaces between cells, essentially because the approach that I have preferred and promoted for stuff that's outside the cell is essentially to get it inside using vaccination and stuff like that, because inside the cell we have much more high-powered catabolic machinery in the lysosome especially, whereas inside the cell things only accumulate because they are by definition resistant to degradation by even the lysosome. And so one has to do things like introducing enzymes from other species or other techniques of that sort. So there, we're not quite that far along. We're close, though. There are a couple of the approaches that we've pioneered that are probably going to be in clinical trials within a year. So that's edging out of my area of focus, if you like. And then there are other things that are really hard. So, for example, one thing that happens in aging is the accumulation of mutations in the mitochondrial DNA, which happens very much faster than the accumulation of mutations in the nuclear DNA. And the approach that I've been pursuing for the past 15 years or more is to make copies of the mitochondrial DNA and stick them in the nucleus, modified, of course, in such a way that they still work, even though the DNA is in the wrong place. In other words, the protein has to be re-imported back into the mitochondria the way that well over 1,000 proteins naturally are. And you've only got 13 proteins that we need to do this for, but still, it's a very hard job. And we're far closer to making it all work than anyone 10 years ago would have believed that we would ever be able to get to, but we've still got a long way to go.
Quick follow-up question. That was all fascinating, but just one I wanted to ask you about is, what is it about mitochondrial DNA that makes it mutate at a higher rate than nuclear DNA?
There's quite a few reasons. The first reason is it's a really bad place for DNA to be, because it's right next to the respiratory chain, which is where most of the free radicals that the cell creates are generated. But there's also more to it than that. There's the fact that there is simply less sophisticated DNA repair machinery in the mitochondria, and indeed less sophisticated DNA protection. There are no histones, for example. So there's a whole bunch of things. One might ask, why did evolution not care about mitochondrial DNA? And, it's a good question. But, even though mitochondrial mutations accumulate much more rapidly than in the nucleus, nevertheless, they're still relatively low in abundance, even in old age. And the reasons for believing that they are important as contributors to age-related ill health are still relatively indirect and circumstantial. They're pretty strong, but they're indirect. And the mechanism is still not clear. There are various proposals that I and others have put forward for how a small amount of mitochondrial mutations can be amplified in terms of its impact, rather in the same way that a small proportion of senescent cells have, pro-inflammatory, this thing called the SASP, as they call it. But yeah, it's still rather unclear.
You briefly mentioned free radicals. I know that's an important concept. Can you explain for the audience your perspective on how it plays into the aging process, and if you're doing anything to address that?
Yeah, sure. So, of course, yes, the free radical theory of aging was the very first properly mechanistic theory at molecular level of how damage is created in the body. The respiratory chain, which is the source of most of ATP, the main way in which the cell extracts energy from nutrients, is a really hairy thing that's only evolved once in the whole history of life, and it gets things wrong sometimes. The intended function of the respiratory chain is to take electrons from, mostly from the Krebs cycle, and to transfer them to oxygen, and in the process create carbon dioxide, which releases energy, and that energy is used to regenerate ATP from ADP and phosphate, which is all very well, and it was all worked out in 1961 by Peter Mitchell. But the problem is that occasionally the electrons that are transferred out of the TCA cycle do not find their way to oxygen in the correct manner. They find their way in an incorrect manner, creating something called superoxide, which is a free radical, a molecule with what's called an unpaired electron. And after that, all hell breaks loose, because the process of, because free radicals are highly reactive, and a lot of things can happen. And we have a lot of machinery, both enzymatic and in terms of vitamins, that minimizes the extent to which free radicals cause havoc, but they certainly do not minimize it to zero. So this is a major source of the long-term accumulating damage, not only to mitochondrial DNA, but also to lipids and proteins that that eventually leads to age-related ill health. And in terms of what to do about it, well, of course, this again comes back to the question of slowing down the creation of damage versus repairing it. The approach that Denham Harmon, the creator of the free radical theory of aging, first proposed was simply antioxidants, molecules which react just like anything else with free radicals, but the reaction product, which is itself a free radical, is unusually unreactive, and therefore it kind of detoxifies the whole problem. Unfortunately, antioxidants basically don't work, or hardly work, because it seems that the free radical reactions that matter happen so fast that essentially, and in locations that antioxidants do not tend to be able to have much impact on. But conversely, if one is going in one step later, one is actually, accepting that damage is going to happen as a result of free radicals, but then one repairs that damage, then one kind of, gets around that problem.
What are some of the ways that that can be repaired?
Well, so all of the things I was just mentioning. So, for example, waste products inside cells are very often accumulating in the lysosome because the molecules in question are so cross-linked and messed up that they are simply no longer substrates for any of the dozens and dozens of hydrolytic enzymes that the lysosome contains. And many of the, in fact, most of the chemical reactions that create this Gordian knot that these enzymes can't do anything about are free radical-based reactions. So that's just one example.
Mm-hmm. Thank you.
I've got a follow-up question on that. How soon do you think people will see significant healthy life extension effects from the work you're doing, or just generally in this space? When are we going to see a bump in things?
It's a great question, and I wish I knew the answer. But I think we could be talking only a decade or two away now, because the damage repair approach, being a divide and conquer approach, is clearly going to need to be translated to the clinic as a panel of therapies that are provided to the same people at the same time, so as to fix a whole bunch of different types of damage simultaneously. But we're getting there with these things, and what's most important to remember is that there is crosstalk between the accumulation of different types of damage, in the sense that the more of one type of damage you have, the more inefficient the processes we have that limit the rate of accumulation of all types of damage. So, for example, a decade ago, when people first started exploring in mice, in genetic models initially, the impact of removing senescent cells, they found, to I think everybody's astonishment, certainly mine, that there were very widespread benefits to the health of the mice that were given this intervention. And, so widespread that you couldn't even really hypothesize what the mechanism was for why removing senescent cells would have these knock-on effects. But the knock-on effects were very broad, which of course means that we could end up being able to get away with a really rather incomplete portfolio of damage repair interventions and still get a significant benefit in terms of prolonging healthy lifespan. So I don't know, but I'm quietly optimistic that we are getting there pretty fast. I should actually mention in this context that one of the major new activities, in fact, really probably the centerpiece of my new foundation, is going to be to push forward exactly this, to do combination therapies. We will only work in mice, not humans, because humans are expensive. But we are going to be taking middle-aged mice and doing combination therapies on them, having done nothing to them at all until they got to maybe within 1 year of their life expectancy. And the goal will be to reach the milestone that I have historically called robust mouse rejuvenation, which basically means doubling their remaining lifespan.
Yeah, it's a fascinating idea. We've talked about the interventions testing program and the work on mice there. So your project will sort of take this to the next level and because they're obviously limited in the number that they can do. But how will your project compare with the existing work done on mice and longevity?
Yeah, thank you for asking, because absolutely, this will be another case where we definitely do not just want to duplicate effort. So the main difference is that in the ITP, and indeed in other efforts along of that nature, such as work that's starting up now at the Buck Institute, also work in Singapore under Brian Kennedy, those are all basically looking at dietary interventions, at orally available stuff. And that's great, but we firmly believe that that's not going to cut it, that we need to go into stuff that needs to be injected in order to really have the maximum effect. And the reason why that has not been done in these other programs is basically cost and efficiency. They basically say, well, if you're going to be doing something every day, it's got to be something you can do really easily. But of course, the interventions that we want to do not have to be done every day. Maybe they only have to be done once, or maybe only a few times during the lifespan, during the treatment period. So we believe that is a misguided, honestly, limitation of these other programs. And we will be focusing very strongly on things that are explicitly damage repair, and therefore only need to be done occasionally, or maybe even only once. But we are absolutely not shying away from doing stuff that needs to be injected.
Yeah, that's so exciting. I can't wait to hear the results of those projects here. You're involved in so many things in the longevity space. I'm wondering, are there any areas of longevity that are very exciting to you that you haven't been able to get involved in? Or what's the most interesting things that you're not working on in longevity?
Well, I mean, we, of course, we're a small organization. I mean, both my organizations, SENS Research Foundation and the new one, are small. So we can't do everything. But equally, we are constantly looking to update our priorities. I have one person working for me, Caitlin Lewis, whose main job is to answer that question, ongoingly, to identify and consider new priorities that we may have.
Great. Yeah.
So if for our audience, can you identify a couple of very practical things that are available right now that the audience can follow that would maybe have an impact on their longevity?
Yeah, well, of course, I'm a PhD, not an MD, right? So my area of expertise is very much what doesn't exist yet, rather than what does. And I think Robert has very capably demonstrated, not only, not least in his new book, that you should really listen to him more than to me on that matter. But I really think that the only fundamental thing that can be said is pay attention to your body. In other words, everybody's metabolism is different, and everybody has their own things that they have to pay attention to. I'm one of those repulsively lucky people who can eat and drink exactly what I like and nothing happens. I don't even need to do any exercise. And I'm biologically far younger than I really am. But of course, most people are not like that. And so paying attention to what your body wants you to do is really the fundamental thing.
One quick follow-up question to that, Aubrey, as an expert in this space, would you be comfortable sharing anything that you do personally with you said nutrition's fine and everything. Are there any supplements you take or any sleep habits, or you said you don't exercise, anything at all that you do that you could share?
No, yeah. I mean, this comes back to what I just mentioned, that my biological age is very nice. And I've been fortunate to be able to get really high-end tests of that every few years for the past 20 years, and I always come out ridiculously good. So of course that means that for me the rational thing to do is to be conservative. If it ain't broke, don't fix it, kind of thing. Even things that one might generally believe to be good for most people might not be good for me. So I'm obviously, I always pay close attention, and I'm looking out for any early signs of anything going wrong in my body. But until such signs start to emerge, I'm taking a conservative approach and just living the way I've lived since I was 20.
How can people reach you on social media? What's the best way? We're going to put your website and everything in the show notes, but anyone who's listening to this on audio as well, what's the best way to reach you and follow you?
Yeah, I'm easy to find on Twitter, LinkedIn, Facebook. I would give you my email address, but it may be about to change because I'm, as I mentioned, starting a new foundation. But yeah, social media is the right way to find me, and it's very easy. There's only one Aubrey de Grey.
And has the new foundation, do you have a name for that yet, or that will be forthcoming eventually?
That will be forthcoming quite soon.
Well, great. I want to thank you so much, Aubrey and Steve, for spending an hour with us today and sharing the great ideas you're doing. I'm a big fan of your work, Aubrey, and it was wonderful to have you on the program here.
Well, likewise. Thank you so much for having me.
If you are enjoying this program, please hit that subscribe button, or even better, leave a review. Your support makes it possible for us to create the quality programming that we're continually striving for. Also, let us know if there is a certain topic that you would like to see covered or a particular guest that you would like to hear from.
This is for general information and educational purposes only, and it's not intended to constitute or substitute for medical advice or counseling, the practice of medicine, or the provision of healthcare, diagnosis, or treatment, or the creation of a physician, patient, or clinical relationship. The use of this information is at their own user's risk. If you find this to be on the value, please hit that like button to subscribe to support the work that we do on this channel. And we take your suggestions and advice very seriously, so please let us know what you'd like to see on this channel. Thanks for watching, and we hope to see you next time.